Good morning, welcome back. So today's topic is designing logical circuit or electronic circuit, whatever be that. So basically the logic gate, AND gate, OR gate, NOT gate, even NAND gate and NOR gate, these are used to develop a circuit for any kind of Boolean expression. Okay, as I told you before, what is a Boolean expression? The Boolean expression is the representation of a Boolean, of a logical problem. That means if we want to solve any kind of logical problem, that problem can be solved using a Boolean expression, or the solution of the logical problem is a nothing than a Boolean expression. Okay, we can we can evaluate the Boolean expression for minimizing the Boolean expression. Once we have the final Boolean expression for any kind of logical problem, the next thing is to develop a circuit for that particular problem. So when we are using the circuit, when we are developing a circuit, we have to use some gates like AND gate, OR gate, NOT gate, sometimes NOR gate and NAND gate also. Okay, so in fact this AND gate, OR gate, NOT gate, as I told you, these are the switching circuit inside the ALU. So switching circuit inside the ALU, if you are getting that switching circuit outside of the ALU, suppose you want to perform this operation outside of the ALU, so specific integrated chip or IC is available for all these kind of gates. That means to solve OR gate we have a different IC, to solve AND gate we have a different IC. So connecting these ICs, actual circuit has been designed, but before that, how to connect those ICs, that can be drawn using a circuit diagram. So we'll see how we can design a circuit diagram. For that I have taken 5 different kind of example. The first thing which are familiar to all of us, that is the XOR gate and the XNOR gate. In the last session only we learned about the XOR gate and the XNOR gate. So the XOR gate logic is, suppose this is F is equal to X dash dot Y plus X dot Y dash. So when we are going to solve this logic, or we have to design a circuit for that particular logic, then what happened? First we have to take two variables X and Y. Okay. The designing of the circuit is completely depending upon you. Sometimes I take the input like this in horizontal manner, sometimes in vertical manner. I will show both of the way how can we develop circuit. So here I am horizontally, I am taking two variables. So the first term, that is X dash dot Y. X dash means X must be passed through, not get, so it will get the X dash, and dot Y, that means X dash and Y. These two are should be passed through a AND gate. Okay, so first what happened? We are passing X in a NOT gate. So I am getting the X dash now. What happened here? After getting the X dash, Y is directly come over here. Now I am using an AND gate here. This is the symbol of AND gate. So up to this will get X dash dot Y. The second thing, that is X dot Y dash. Now I am taking X. From this I am taking X. From this I am taking Y. And for getting the Y dash, I am passing Y through NOT gate. So this is the Y and this is the Y dash. I think you can get it. Whatever the way we get the X dash, the same way we are getting the Y dash. After getting the Y dash, what happened? Join this into a AND gate. Now we'll get both the terms, that is X dash dot Y, the upper one is X dash dot Y, X dot Y1, the below one is the X dot Y dash. Now we have to use an add operator between these two things. That means an OR operator has been used between these two terms. So for using an OR operator, this is an OR operator, and here we have the solution. Like this, if I am connecting the AND gate and OR gate, then we'll get this value or this Boolean expression. That is x passed through a NOT gate, so that we'll get this x dash. Now y is directly ANDed with x dash. Now these two values are passed through your AND gate, so that we'll have x dash dot y. After that, in the same manner, we are having x directly and y passed through a NOT gate, so we will have the y dash passed through an AND gate, so that we will have now x dash dot y over here. Now for adding both of these values, we have to use a OR gate, so that we will have x dash dot y plus x dot y dash over here. So this is the design or circuit for that particular Boolean logic. Now if you go for the second thing, that is x dot y plus x dash dot y dash. Okay, I think you can understand now. X, y pass through AND gate, so that we will have x dot y NOT gate will have x dash. Again through NOT gate we'll have y dash. Again through AND gate we'll have x dash dot y dash. Now pass these two gates through OR gate, so that we'll have now x dash x dot y plus x dash dot y dash. Again I am repeating the process. X and y directly pass through the AND gate, so we'll have that x dot y. Now x through NOT gate, so here we have x dash, here we have y dash. So here we have x dash dot y dash, here we have x dot y. And when we are passing both the terms through OR gate, here we have the complete expression, that is x dot y plus x dash dot y dash. So these are the circuit diagram of first two expression. Now come to the third expression, having three variables over here. Here we have the three variables. So in this case, three variables, as I told you, we can take the input as horizontal manner as well as the vertical manner. When we are using three input or three variables, in that case a better idea to take the vertical input. Okay, so there are three input x, y, z. The first term is x dash dot y dot z. The second term is x dot y dash dot z. So here I am taking three variables x, y and z. So let's have the first thing, that is x dash. So I have to pass through NOT gate. Here I am getting x dash. Then y is directly without having NOT gate. Z is directly without having NOT gate. Now all these three can be passed through a AND gate for dot operator. So together all these three I am passing through a NOT gate, AND gate. Now this is the first term, that is x dash dot y dot z. Now come to the second term. Here y is passed through NOT gate. So I am passing y through NOT gate. Z, normally taking z, and x is also taking normally. Now here we have, this is z, this is y dash, this is x. So here both the inputs are passing through a or gate. So that will have this plus operator over here. Okay, so this is the way of solving or designing a circuit having 3 variables. Now go for the next case. I am going for the 5th number now. This is for you. You have to solve this 4th expression. Okay, because there is no difference between the 3rd and the 4th. The same way you can do the 4th operation. So I am going for this OR operator here. This is the something different from these two, where we have to first solve the OR operator, then we have to solve the AND operator. Because here first the OR operator has been used, then the OR operator AND operator has been used. So better suppose x and y, x dash. So we have to pass x through NOT gate. We'll have x dash over here. Now plus y. So here both are passed through OR operator, so that we have x dash plus y. The second thing is y dash dot z. So z we have to take as another variable over here. Before that I am taking y dash. Now z is the 3rd variable. So directly z, use OR operator. So here we have the value y dash plus z. Now use these two with a and z, so that we'll have the final expression over here. So this is the way how you can design a Boolean logic circuit or draw a logic circuit for any kind of Boolean expression. Okay, in the next class we'll go for logic circuit or circuit design using AND gate and NOR gate. After that, try this 4th question by yourself. Thank you and have a wonderful day.